Hello all and welcome back. So in this video, I would actually like to help you visualize the different time complexities which we have actually found till now. So we have done so many problems on time complexity and gotten so many relations: linear, quadratic, exponential, logarithmic, right? I would like to now actually pause and help you visualize these complexities, okay? So that you can actually appreciate and think that, okay, how you have to solve questions, as well as I will tell you how exactly some constraints affect the solution which you can present to your interviewer, or let's say in any lead code or any other website, or like online assessment OS, right? So let's get started. Now first I would like to show you the complexities. So see, this is the operations and this is the element, like the n and the time, right? So see how many operations are happening, right? So I would like to just explain this. Yeah, great. So for O1, of course, it is very much less, right? So number of operations are very less. If the operations are less, then of course the time is also going to be less. Similarly for O log n, this is the case. For some On, this is what we are getting for some On. N log n is also fine. You can see that, okay, this is bad, but it is still fine. Merge sort was n log n, it is still fine. The problem happens when we go on exponential and square. So On square is horrible. 2 to the power n exponential is very bad. And this is factorial, On factorial, right? This is also again a lot bad. Let me help you to just visualize this a lot more better as well. So let us use Desmos. So again, this is just a graphing tool. Okay. Let's say when my y is equals to 5, some constant. Okay, let me take it 1. You can see, so for the time being, let me just have it here. Okay. What you can assume I will write down that this is your time and this is your input size. Okay, this is your input size, the n basically. Now for a constant time, it doesn't matter. Finding middle element of an array, you can increase the input as much as you want, but it's not going to have any effect on your time. Let us see for other cases. For y is equals to log x, it's still pretty good, right? It started, but then it is just a little bit above, pretty good. It won't be affecting that much. We saw that, okay, how it's for a million, it's just 20 comparison. Right, let us move forward. Y is equals to x. Yeah, fine. Still workable. We have to go to each and every element and do our work. Y is equal to s is like this. Next is y is equals to x square. Okay, now this seems to give me a little bit problem because this is increasing a lot quicker. So as soon as I am on my, let's say 5, some input size is 5, I say that it is 25. As compared to just 5 or very less in terms of other complexities. But talking about a very large number, of course you can see that how fast it's going to grow, right? Great. So next one, now let's say take x log x, okay? Better than x square, worse than linear, still fine. I can still work on it. It's not bad. Yes, it's a little horrible. And one thing more you have to understand, that it's not always on us that we can, for any given problem, we can get any complexity we want. No. The problem, the one way it can be solved is, for example, to do a searching in a unsorted array, you cannot do it in less than O(n) time. You will have to make sure that you get to each and every element. So for linear search, if the array is not sorted, you have to go to each and every element. Okay, it is not in your hand that you you want the log n, let's say approach, log n complexity. No, it is not how things work. You have to go to each and every element, so it's going to take that much. Now let us see 2 to the power x. Pretty bad, rather horrendous. Anytime you are getting this much complexity, it's very bad. Okay, we should see what we can do, or if the problem is like that, or we can do something to avoid in our code. The last one, normally, which we have not seen, it will be encountered in permutations like code. It is x factorial. Again, this you can see it is even better than 2 to the power x, the exponential one, and how badly it is increasing, right, with respect to the time, with respect to the input. So these are the different complexities which we have actually found out. We didn't get, I think, x factorial anywhere, but should be fine. I also showed you how they are in terms of comparison with each other. So O log n till On is fine. N log n is also fine. On square, normally we will see that, okay, if some other is available. And same for other like these complexities as well. Okay, I will add this big O cheat sheet. Let me add in one of your resources. So one thing more to just tell you all, I have also attached a very good resource where you can practice. Okay, so these are the questions of time complexity which I want all of you to practice. The good part, solution is also written in like after this. So solution is also there which is explaining everything. Okay, so please make sure that you try this out once everyone. This will be a lot helpful to you. So the solution is there, so you don't have to worry on anything. If anything is not clear, sure, you can ask the same. So this will be a lot helpful in revising all the concepts. Again, we have done so many algorithms, so I'm pretty sure each and every question in this sheet you will be able to do. Just make sure that you apply the understanding which I have shared with you, the approach which we have shared, and that should be fine. Okay, cool. So with that, I hope you are able to visualize how the algorithm looks like, and you also get an idea that how you can now just master everything in time complexity by doing this sheet as well. It has 10 questions. So yeah, great. Now I would like to show and actually have your attention in some other part, that is, if we do any questions on LeetCode or any other online assessment or anywhere, you will always see that there are constraints which I mentioned, right? So num's length is less than equal to 6. Here if you will see, num's length is less than equal to 5 into 10 to the power 4. Can these be helpful to me in any interview or any, like when let's say I'm doing this question? So I can just tell you one thing. Okay, let me just put it down. Just by looking at these complexities, I can say that this particular code, this particular solution, it will not accept the bubble sort algorithm. How can I say that? Let me just show that to you as well. And then I'm going to teach you properly how you can use these to your advantage. Let us copy this code of bubble sort. Okay. And let me just go to LeetCode. This is not the one. Yeah, this is the one, I guess, right? Sort an array. Great. So what I'm going to do, I'm just going to copy this code. This code is a perfectly valid bubble sort code. Indenting it. Here it is getting nums. So I'm just going to make it array. Let me try to run it. I think it's going to fail because I've not returned it. Return array. Let me run it now to see that the basic test case pass. Okay, so let us wait in some time and let us run it then. Great. So they are getting accepted. That means the skeleton code is fine. Okay, it's returning everything. Now let me submit it and see what will happen. When I submit it, I'm saying that it should not accept the solution. It should rather give you some error. If you have solved a lot of questions, you will be aware of this error. It is TLE, time limit exceeded. This is some error which like I have actually spent my life on solving, honestly. This is something which we get a lot in competitive coding as well, right? So now let us see how just by seeing this particular constraint, I was able to say that, okay, this is the kind of a solution which it will accept. Now, if we will actually give a merge sort level of a solution, it will accept the same. So let us understand how this happens. Okay. I hope we are able to visualize this properly. Now, let me just help you in this as well. So let us just copy this whole cheat sheet. That should be helpful. 1 second, let me do it again. Along with that, one thing more you all have to see that in this particular website, all these algorithms are written. So sorting algorithm, we have seen that, right? Bubble sort, we found out the worst case O(n) square. Insertion sort was O(n) square as well. Selection sort you must have done. All these were O(n) square. For insertion sort, the best case was omega n. For for merge sort, we found that everything is n log n. So don't remember again. Don't you have to remember, and don't also get a lot scared that okay, how many algorithms are there? No, you don't have to do that. There can be n number of algorithms. If your understanding is clear, which will be by the end of this course, I can assure you of that. You don't need to know every algorithm on this earth. That is not how coding happens. Okay. Companies like even Google, Microsoft, Amazon, they don't want the person to know all the algorithms. They just expect that a person is very smart, that he knows the basic one and will be able to make sense of the new one which will be taught to him. Okay. Great. So yeah, I hope that is now a lot clear. Now let us move to the next part through which you can actually tell the solution. So this is just some table which I have made to tell you that how number of operations basically. So this is how the n is increasing by the factor, and this is then how many operations you have to do, right? Again, for very large n, for this factorial and this exponential, you can see that it is good luck because you will not be able to calculate this, right? It's a lot high. any algorithm, if it is having 100, 2 to the power n is going to be a very bad solution. I just told you that for this particular permutation question, the complexity normally is n factorial. That's why you will see that num length is just 6. It is not 10 to the power something like that, right? Now let us try to better understand all of this, everyone. So pay attention. While doing question on Lead Code, online assessment, Code Chef, Code Forces, these are some competitive website. We faced time limit exceeded. So I just showed you on Lead Code that we were facing this time limit exceeded. And brute force solution, the solution which we normally try, right? Brute force is the very initial solution which you are writing without any optimization, is normally not accepted. The reason for that is normally the number of operations which are allowed per unit second is 10 to the power 8 in most of these websites. Okay. Earlier it was 10 to the power 7, I guess, in some, but now it is 10 to the power 8. Again, I have been coding for 7-8 years of my life, so I have seen that how exactly. Earlier it was 10 to the power in some, now it has increased, and then you get an idea based on these things. So that is something which I am sharing. Now number of operations allowed per unit second is 10 to the power 8. Now the reason I was able to understand that, okay, this is something which is not going to pass is, it is 5 into 10 to the power 4. If now I square this, if I am writing a O(n) square approach, then what's going to happen? This whole is going to get square, right? This is going to become 25 into 10 to the power 8. This is something which is a lot greater than 10 to the power 8, right? So again, I will repeat, this was how I was able to get that. So let me now share this whole approach with you because it's going to be a lot helpful. So in problems on internet, the same is actually provided in the question definition as we have just seen. This kind of constraints are provided and that can be very much helpful to us, right? So this is the kind of a table. Again, you don't have to remember them. I will tell you exactly how you can make sense of it, but should be fine. When we say that in our constraint n, the input is less than or equal to 12, we are good to apply the n factorial solution, right? Now the algorithm which normally gets applied there is backtracking and recursion. So backtracking you are not aware as of now, should be fine. We are aware of recursion, so you can just think of that only. When n is less than 25, when someone says that n is less than 25, then of course O to the power 2n can still be applied. Okay, because we saw that n factorial is even worse than exponential. That means that you can do bit manipulation, recursion or backtracking. Now here again, bit manipulation we have an idea on, recursion we have an idea on. Backtracking is something which we will be doing in future classes, future modules, right? Similarly, when n is less than 100, n is less than or equal to 100, the upper bound is 100, n to the power 4 is accepted. Some DP codes are there which works on the screen. DP is dynamic programming, something we are going to cover towards the end of this course. Very interesting, very nice topic. I like to solve problems on DP. Similarly, when n is 500, O(n) cube, cubic solution is accepted, which again we can do with DP or via loops and everything. When it is 10 to the power 4, then n square solution is accepted, DP, graph and tree. When it becomes 10 to the power 6, let me just correct it a little bit. Okay, 1 second. So due to some reason it is not reading that, should be fine. So when it is 10 to the power 6, then we say that O(n) log n solution is accepted, right? This is the kind of solution which is going to get accepted. When it is less than 10 to the power 8, then of course O(n) is going to get accepted. The mathematical or greedy, direct, just like we actually did for looping or something. And in cases it becomes greater than 10 to the power 8, the input size, then just these two will get accepted. So one is O(n), O log n and O1, right? So mathematical or greedy. For example, finding the middle element, your array can be of 10 to the power 55 as well, doesn't matter. But then only of course your constant time solution, the middle, is gonna work, right? So these are few of the constraints which you can actually use. Now this constraint, because see here now, this is less than 6, so I know that okay, some factorial solution will be accepted here. This is 5 into 10 to the power 4, so I know that n square will not be accepted here. Okay, a better way to remember this, now this write all these algorithms, you will get a better idea when you do lots of practice. For the time being, the better way to remember this is that whenever we choose any algo, so let's say you say that, hey, I'm gonna solve this with bubble sort. Bubble sort I know is n square. Just apply this n square to this length, the upper limit. It's going to be greater than 10 to the power 8, right? If that's the case, then normally what you will see is that solution will not get accepted. So if we plug in the n, we should get around 10 to the power 8. That's the number of operations we are allowed. So this thing is now something which you can remember and is going to helpful to actually solve you the questions. Again, these are something which are not known by many people. Again, based on my experience, is something which I am sharing all of this thing to you, right? Please make sure that you use that in solving the questions, right? In OAs, in your online contest, this is going to be a lot helpful to actually change your mindset, your thought process towards an optimized approach, rather than you wasting your time on writing the brute force or some approach which you know it's not going to get passed. You can save a lots of time and get selected by thinking directly on optimized approach. For example, if I am getting this question in any OA or in an interviewer ask me this, just seeing the constraint, I can say that, hey, I can assure you that ON square will not pass here. Okay, we cannot pass with any of this thing, either your bubble sort or your selection sort, right? So let me just directly try with merge sort. Okay, so if you are able to explain your interviewer this thing, surely he's going to be a lot impressed. And these are the kind of difference, right, which is actually there in people who are able to crack some good product based companies, the tier 1 companies, and people who are not able to, because this level of understanding is a lot required. Now again, I'm not asking you to remember anything. I'm just helping you to build your thought process. And that is something which we are always going to chase, because remembering you will forget. Once you understand things, the way I have understood things over the long period, the way I'm sharing with you all these things, you will be at a very good place and be able to crack any company. Okay. Cool then everyone. So I hope this class was helpful. Please make sure that you see this again to understand all these things which I have told you. They are going to be a lot helpful in your overall programming solving journey, question solving journey. In your notes as well, you are going to get all these things. So please make sure that you revise them and understand what exactly was it. And now next time you are solving the questions, please make sure that you also look the question with that lens. Just keep on solving it normally only. I'm not saying that run behind the most optimized approach as of now. It will gradually happen. As we solve more and more questions, it's going to help gradually. Okay, that's the beauty of DSA. It's built with time. Okay, cool then everyone. Thanks a lot. Let's meet in the next video. Thank you.